Good afternoon, everyone. In this video, I'm going to discuss the question number 8, where we were asked to prove using the third question of number 7 and other results from propositional logic that R implies quantity of P implies Q is equivalent to quantity P and R implies Q. And this time, we're not going to use the truth table. Instead, we will use the laws. So let's see how this works. The third question in number 7 is P implies Q is equivalent to negate P or Q. So I'm gonna start with this statement. On the left hand side, P implies Q. Now we have to ask ourselves, what's another way to write some or all of the elements of this statement? So I'm looking especially at P implies Q. And here in implication law says that P implies Q is equivalent to the statement not P or Q, which is true. So the third question in number 7 is implication law. How about question 7i? P implies Q is equivalent to negate Q implies negate P. So same process pa din. Just look at the laws, and here in contrapositive law says that P implies Q is equivalent to negate Q implies negate P, which is true. So the question number 7i is contrapositive law. How about question number 7ii, where the statement is the negation of quantity P implies Q is equivalent to P and negate Q. So here in conditional equivalence law, or conditional statement part 5 says that the negation of quantity P implies Q is equivalent to P and negate Q. So which is true. Therefore, question 7ii is conditional statement number 5. Now let us try to use these laws and other laws to prove the statement R implies quantity of P implies Q is equivalent to quantity P and R implies Q. So here we go. I'm gonna start with this statement on the left hand side. R implies Q, quantity P implies Q. R implies quantity P implies Q. So we have to ask ourselves, what another way to write some or all of the elements of this statement? Well, here in implication law or conditional statement part 1 says that P implies Q is equivalent to negate P or Q. So what I'm gonna do here is to replace a piece of this left hand side with something else to which illustrate logically equivalent that will keep the entire statement, including with the negation logically equivalent. So I'm going to replace this as negate R or quantity P implies Q. Now what I am thinking at this point on the right is the implication law, conditional statement part 5, which says negate P implies Q is equivalent to P and negate Q. So I'm going to rewrite this one according to this law, and it looks like this. At this point, we're going to use associative law since they are quite similar, so I'm going to rewrite this one in this way. This time, I'm thinking De Morgan's law since the statement are also quite similar, so I'm going to write this one in this way according to De Morgan's law. At this point, I'm thinking implication law or conditional statement. So I'm going to rewrite this one, and it looks like this. And in this moment, I'm thinking about commutative laws, where it says R and P is equivalent to P and R. So we have P and R implies Q. And that's exactly what I wanted to prove. So even though the logical statements are all not equal, but logically equivalent through a collection of logical laws.